Hello everyone, this is Spencer Snowling from Hydromantis, and I'm welcoming you today to our webinar that we're going to be discussing the new release of GPSX, which is release version 6.4. So, my name is Spencer Snowling. I'm Vice President of Product Development here at Hydromantis, and I'm glad that you can join us today. This is one of a series of webinars that we've been doing over the past 3 years or so, and that we do about once a month. Excuse me. I realize this is actually probably a much better time of day for many of you that are joining us from Europe. We are going to attempt to try and hold a few more of them at this time of day so that we can spread our available webinar series to a much broader range of time zones over the next little while, and I'm going to come back and discuss that a little bit later on about some of the upcoming webinars that we have and some upcoming GPSX training opportunities. Today, though, we're going to be talking about the new release of GPSX version 6.4, which is coming out just about right now. There are a number of new software features. As always, whenever we put out a new version of our software, we work to try and improve the interface, make it easier for you to use the software. We, of course, always try to improve the content of our models, and so we often put in new objects and new wastewater content, new features that will allow you to model wastewater treatment plants in a much more robust and straightforward way. So as part of the introduction of those new features, I am going to be showing you some slides today, and I'm going to do a couple of desktop demonstrations using version 6.4. I'm going to discuss, as I mentioned, a few upcoming workshops and webinars that we have going on, and then, of course, I'll answer any questions that you have at the end of the webinar. So you may have noticed that in your GoToWebinar dashboard, there is an opportunity there for you to open up the questions panel and type questions in there. So the way that we usually do this is you can please feel free to type any questions that you have in there as we go along, but I'm going to hold off on answering your questions until we get to the end, and I'm happy to stick around for 5 or 10 minutes and answer any questions that you have about GPSX, either about the new version that we have here or just about GPSX in general. Excuse me. Okay, so moving forward, GPSX version 6.4, we highlighted and demonstrated to our North American user base at the WEFTech conference in New Orleans about 3 or 4 weeks ago. We were very happy to do that. That was our 5th new release of GPSX in 5 years. We've had some very good feedback from our clients about making a new version available every year with new features and new wastewater models. So as I mentioned, every time we release a new version of the software, we try not to focus too much on one side or the other, but we try to make sure that there's an improvement on the software side and an improvement on the wastewater engineering side, and we try to balance those as we develop and improve our software going forward. So in addition to a number of new things, there's updates to a number of the existing models that we have in the software, and I'm going to talk about that a little bit. There's, of course, always bug fixes, so we get a lot of good feedback from our users during the year, and that goes into improving the software and fixing up anything that might be an issue. And also, we're laying the groundwork for some future updates, too. A few things that are going on behind the scenes, preparing for us to be able to incorporate new things into GPSX down the road. So, before we go into those details, if you're wondering whether you will be receiving this new version or not, the way this works is that users who have either a yearly subscription, if you have an annual subscription, an annual lease of GPSX, you will automatically get this new version. Or if you have a perpetual license and you have an up-to-date technical support contract, you will automatically receive these. And the way it works is that you will receive an email from us with a new key code and with a link to where to download the software, and you continue to use your existing hardware key. So if you're not sure, you don't know whether you are qualified for that automatic upgrade, or if you're interested in upgrading your license so that you can receive version 6.4, please contact us at support@hydromantis.com, and we'll let you know how that's going to work. Okay, so let's talk about the software interface side first. And here, I'm going to talk a little bit about the tools that we have developed to handle data in GPSX. So previously, whenever we wanted to display some real measured data alongside of our simulation for doing a calibration, for example, we would have to do that on an XY time series graph, and that was something that showed data points here with these dots along with the simulation, but it had to be something that was over time. Now you can plot model results alongside bar graphs and digital graphs as well. So that means that you can do this for steady state as well as dynamically. So we've increased the types of graphs that you can use where you can use this particular feature. So in this particular case, and I'll show you a dynamic version of this in a moment, the way that this works is it's showing here the solid bar is the simulation and the hatched bar is the data point. So as things change over time, you can run your simulations and know that this is the particular point that I'm trying to plot to, and I can adjust in my calibration and see that goes along. So that way it's a nice easy way to see your data and your simulation side by side. And for our features where we are showing that with a digital graph where it's just reporting the output from the end of the simulation, we're doing the same thing here. This is the simulation on the right-hand side, and then there's a column of data that's being read in, and that's what's being displayed on the left-hand side. So just to let you know, of course, getting the data into the software to be plotted on these graphs works basically the same way that it always has. You can prepare an Excel spreadsheet, and then you can use the configuration menu to associate that spreadsheet with your particular scenario that you're working on. Now, speaking of scenarios, we've made some adjustments to the way that the scenario menu works, and specific the scenario show menu. So previously, if you're familiar with using scenarios, that's where you create a set of temporary parameter values that you can associate all together under one name, and you can sort of store a number of parameter settings together in one place. So this is quite frequently used for doing calibration, or particularly if you're setting up two different simulation scenarios where you have something that you're taking out of service, or you have a winter loading and a summer loading, for example, and you have a large number of parameter changes. And when you went to the scenario show menu, you would see all of those changes there. So what we've done is we've reorganized that menu now so that it's grouping those changes grouped by object now. So these are all of the parameter changes. Before, it was done in a bit of a chronological order as you built up your scenario over time. And even more importantly, you can get access to change the values directly in the menu, whereas previously you had to go back and find where that parameter value was in the menus of the various objects in GPSX. So this has kind of made things a little simpler and a little more straightforward for you to use. I'll also mention that we have changed the way that we do defines as well. So if you are a GPSX user and you're familiar with defining, say, a daily average or a moving average, or you are integrating a mass flow over time or something like that using our define function, you may recall that you would have to, if you wanted to do it for several different places in the layout, you would have to open up many menus, basically one for every connection point where you wanted to define a new variable. And so now we have changed this over so that it works very much the same way that our tables work, in the sense that you can go here, click off a number of these particular objects where you want to define, say, your moving average, and then you would click which variables you would want to do, and then it would do it across all of the objects, all of the variables, and it's really straightforward, and it saves you time, particularly if you're doing a lot of them across a large layout. Okay, so let's take a look at those actually in GPSX here. So I'm going to start by showing you the example of how to plot data alongside a graph. So previously, I'm going to use one of our examples that comes in GPSX, and I'm going to show you a simulation where we run 4 days worth of dynamic data. So these graphs here, like this one, are ones that you would typically be used to seeing, where we have data points shown with these dots and the simulation shown with the line. But just to let you know, you can now do that with these bar graphs as well. And as a matter of fact, I'm going to run that again, just slowing this down a little bit because it goes by very quickly. So, and you can see here in this particular graph how the shaded part is the data point that's being read from the file, and the solid part is the simulation. So you can do those comparisons side by side, either at steady state or dynamically. And of course, the same thing goes for these effluent numbers here. These data points are being read from a file, and they're showing next to the digital output that we have there as well. So I'll also indicate too, I should have shown you the new scenario feature there. If I go to this scenario show menu, you can now come here, see the organization of all the values that are in your scenario. You can obviously go in and change any of these now very easily right on the spot, and that works pretty well, and it's nice and easy to be able to handle that data. And lastly, very quickly, I'll just show you that define the daily average, and you can see here I can click off as many of these particular objects as I want, and I could do a moving average on ammonia, for example, here, and be able to define those all very quickly. And then when you go back to the effluent connection point menu, you'll find those defined variables in the same way that you would always have found them in the past. Okay. So, a few other features that we've added. We've changed the way that the open dialog box works when you're opening a brand new layout. So previously you would have just seen the listing of the files. Now when you click on one of those files, you will see a drawing of the layout. You'll see a bit of text which you can edit that will describe of how that layout works. And we've also incorporated some of that functionality into our sample layouts menu. You may have previously remembered that this was a menu that sort of unfolded to the right and was allowed you to sort of browse down several layers. We've replaced that with this option now, which allows you to sort of browse through the layouts that we provide to you. As you may know, we have created about 60 or so typical treatment plant layouts that are there to highlight different individual unit processes, and the ones that are showing here are for COD removal, nitrogen removal, phosphorus removal, and so on, and they're different designs. And these are already done, laid out, all of the connection points have been put together, and the internal recycle specified, and so on, and you can access these. And now there's a nice, easy way to see how that all works and what each one of those layouts does. And lastly, for our new software interface features, I'm going to talk about the Sankey diagram. So a Sankey diagram is a nice way to be able to show a flow, or indeed a excuse me, a mass flow around the plant, and do it in a very visual manner. So whenever you draw a GPSX layout and have successfully run a simulation, we now have the opportunity to plot from the drawing board automatically one of these types of diagrams. And you'll note here that I'm showing here in this particular case the flow. The values of the flow are printed right on the lines all over the layout that we have shown here. And we also are now plotting, and this is what makes it a Sankey diagram, a line that is of a variable thickness, and the thickness is proportional to the value that you have. So as you can see here where we have a flow showing, the flow is thick in the areas where the influent is coming out, and of course where the mixed liquor is moving around and out the effluent, and of course we have a smaller flow being used to come down here through the thickener and out through the digester. So it's a very handy, very visual way to assess your entire layout very quickly. So I'm going to flip over to that particular layout right now, actually, just to show you. And I'm going to run a simulation, and I'm going to generate that diagram. It's a new button up here at the top, this red one here, called Sankey diagram. It pops up its own brand new window, and here's that same result that I was showing you before. So you can actually adjust the line thickness and so on, and export this image and that data out to another Excel report or Word document or whatever you would like to be able to include it in. And we can see here that this flow is showing here as it goes around. We can actually do it for solids. Of course, most of the solids in the plant are here in this mixed liquor recycle, and you can do it for ammonia and other things as well. So it's a nice, easy way to sort of illustrate it, particularly for the flow. I find it's a good way just to troubleshoot, make sure the flow is moving around the plant in the way that I thought it would. Okay. So I'd like to move on now to the wastewater content. So leaving a bit of our software stuff behind, now looking at the new wastewater models that are available in GPSX. Before I get into new objects, though, I will say that we've made one change which I found very helpful now, which is to make some of the most commonly used settings for the site, the actual physical location of your wastewater treatment plant, the physical settings, and also the model settings, and then we move them all into one menu that is now available from this Site Properties button. So for example, you see things like liquid temperature and elevation above sea level that describe some of those important parameters that are taken into account when we're doing the biological rate calculations, and also when we're doing the aeration calculations. The elevation above sea level is very important for that calculation. Those are things that you probably would want to have set, and they used to be buried away actually in many different places, and so we've now brought them together here on one menu. Other things that are very handy too, such as the default stopping time for your simulation, and in the case of when you're using our comprehensive model, the Mantis 2 model settings where you can turn certain biomass and inorganic precipitates on and off. You can do that directly from this menu here. And then lastly, the plant information. This is new. This allows you to type out actually any sort of description that you would like to have about the plant. You can type the plant name and the description of what this model is for and so on. And it's actually this information that is displayed in the open dialog box that I showed you earlier. When you are opening your layout, you can now see an image of your layout, and it's actually this information here that you can edit for any particular model. Okay, so we now have a couple or three sort of new wastewater type objects that are here. Some of them are new, some of them are actually rearrangements of existing models that we had. The one that's definitely a new one is our new anaerobic MBR object. So we have a membrane bioreactor in this case that is anaerobic, so obviously not aerated, and it is completely mixed, and you can see the usual symbol that we use for filtration. And you'll note here too, of course, that it is a closed object, so it is capturing the solids here, keeping them inside, and it's a closed object, meaning that we are capturing in a headspace the gases that are being released from the biological activity. So like the digester and like our UASB object, you can actually get a prediction of what the gases, what the headspace concentrations are and what the gas production is going to be like. We have a couple of new objects that are there to help us define the energy usage throughout the plant. As you probably know, GPSX does calculate an estimate of the energy requirements for doing things like aeration for blowers and for pumps for internal mixed liquid recycles and wastage and so on. And so we're now adding on a few other things for doing energy. One of them here is a building. It doesn't actually connect to anything or have any input into how the process of the plant is going on. It doesn't do any treatment, so to speak, but it does use up some energy, and it gets calculated and added into the overall energy calculation for the entire plant. So you can put one or more of these objects down as needed. You specify the use per square footage and how much square footage that you have for that plant, and then it's included into the energy calculation. We also have a new object that is a pump. You can actually add this into any stream that you want. Just throw that one down and connect to and from it. And then you can specify whether this is a variable speed pump or a constant speed pump, and then you have a number of pumps that are operating in parallel, so to speak. You can define the system curve. You can define the pump curve here, looking at the flow rate and the head and the efficiency at the various pumping rates. And then we can, from that, as the flow is moving through that particular object, require the amount of energy, or calculate the amount of energy that is required to pump that flow rate. And so it's a fairly new thing. It's quite a bit more sophisticated approach than what we've taken with some of our pump models in the past. And so this is a new feature that you can access to, and you can use it in any way you want. There's a lot of flexibility in the sense that you can add it to whatever stream that you want to be able to use. And of course, all of these energy calculations are included in the overall summation of the energy used for the whole plant. We also have a new sludge discharge object. Again, it doesn't do anything in terms of treatment, but it does allow you to calculate a new sludge disposal cost, and it does also sort of indicate, by putting this truck on there, a little bit more visually exactly how your sludge is being handled in your particular system. We also made a couple of changes to our dewatering as well. So as you may recall, the black and blue object that we had that was a sort of very generic dewatering object was getting a bit overloaded with 6, almost 7 models that were being used there, and they were all very different from each other. So one thing that we have done is actually broken those models out into their own objects and recalibrated them and given them a little bit better set of default values, and made some changes here. So we now have for various places micro screens, drum screens, disc screens, belt screens that you can use, and these are found at various places through the process table. They're there to do either upstream treatment or tertiary treatment. Some of these are using what we call the differential model, which allows you to specify a different capture rate for inert materials than you would for something like biomass. And other ones are using our empiric model, which has the same capture rate for all the different state variables. But they're there now, and they're a little bit more straightforward to use, and they're a little bit more representative of the type of technology that you would typically see for those applications. And in the same manner, we also had a model in that dewatering object called high rate treatment that was there to do coagulation and settling with lamellas and so on. So we have now moved that out to its own object as well and done a little bit of calibration there. So that's now a little easier to see, a little easier to use now as part of our new list of unit processes. So let's take a quick look at some of those. If you look around here, actually let's flip over to the anaerobic MBR example. First of all, one thing I'll point out is that that new site properties button. It's up here. You'll find that available here. It basically works the same as the other menus that you have in GPSX. It's just now that those really important things that you need to be able to set, such as liquid temperature, are all available here very easily and handily. And here's our new anaerobic MBR object. You'll see that you have to specify, of course, the tank sizes and gas headspace and so on. And very much like our completely mixed MBR object, you specify the solids capture rate here. So we're capturing 99.99% of the solids that are coming out of that particular system. And you can get access to the things such as the gas production and so on. And that allows you to get a pretty good estimate of what's going on. So I've set this example up here. This is one that's available on the new installation of version 6.4. I've set this up to be a bit of a high-strength example, something you might find in a very an industrial wastewater, very warm temperature. And so when that comes together here, let's flip over to the MBR here. And we can see that we can predict the amount of gas production that's going on. We can see significant COD being removed here from 2300 down to 167, for example, and look at our gas production and so on. So it's basically a combination of our regular digester model and the completely mixed membrane model. I'll also mention while I'm here that sample layouts menu. If you click on these particular types of plants here, you'll see different listings for different types of systems, and that information that was I described to you before that you can get from this button up here is now shown over here. And lastly, I'll mention a few places where you'll find those new dewatering objects. If you look in the preliminary treatment, you'll find that belt microscreen there. This is a fairly straightforward empiric model with some new default settings in there where you specify underflow solids and capture rates and so on. And you can find in the tertiary treatment is where we'll have that disc microscreen. This is sort of a cloth filtration possibly. And then in the biosolid section, we can find drum microscreens as well. And this is where our high rate treatment is as well. Okay, so running a little bit long on time here, so I'm going to wind it up. Just mention that we're very happy to have our new version ready to go. You should be getting an email from us in a week or two. There's a combination of new interface features, as I've shown, and new wastewater models. We look to try and help you have an easier way to handle and display the data along with your simulations and improvements for the scenarios, for the defined variables, layout management, and so on, and all of those new wastewater models that we have put in there as well.